We have another example on the board. First, we're supposed to find the impedance of the inductor. So I have ZL is equal to pi FL. This is the formula for the impedance of the inductor or inductive reactance. So I have 2 pi times the frequency 4.5 kilohertz times L, which is 80 millihenries. Everything is equal 2.26 kilo ohms and angle of 90 degrees. Don't forget that the impedance of the capacitor you're supposed to always represent with angle of 90 degrees. Next, because I have given resistance and impedance of the inductor, I can find the total impedance. Z total is equal resistance plus ZL, where resistance is equal 5 kilo ohms plus ZL 2.26 kilo ohms and angle of 90 degrees. This is equal 5.48 kilo ohms and angle of 24.32 degrees. Okay, so this is the total impedance of my circuit. Next, I'm supposed to find I total. So I have I total is equal voltage source over I total, but please notice that we don't have voltage source, so we can say I total is equal also what? I is also equal to what? IR, because this is series circuit, and I can say this is equal VL over ZL, where VL is equal 75 volts and I have ZL we found is equal 2.26 kilo ohms, right? Right now I'm not going to include the angle. So we have I total equals 33.18 milliamps. Someone is going to ask why we do not include the angle, because I don't know the angle which is going to be next to the magnitude of the voltage across the inductor, and this is the reason why I do not include the angle yet. Next, I'm supposed to find voltage source. Voltage source is equal I total times Z total. I'm going to assume, like always, that my voltage source is going to have angle 0 degrees. That's why I'm going to simply use the magnitudes of the current and impedance to find the voltage. I'm going to use Ohm's law. So if I total is equal 33.18 milliamps times 5.48 kilo ohms. This is equal 181.82 volts and angle of 0 degrees. Most of the time I'm going to assume that the voltage source is going to have angle of 0 degrees. Someone is going to ask why. because in my opinion it makes the analysis a little bit simpler. So what I'm supposed to do next? You're supposed to realize that voltage source is my RMS voltage. Why RMS? Because my current is RMS. Why my current is RMS? Because I used RMS voltage, VL was RMS, to find that current. So if I found this current RMS and I use that current to calculate voltage, my voltage is also RMS. Next, I'm supposed to find voltage across the resistor RMS. So VR is equal, I'm going to use voltage division law, voltage source times resistance over Z total. I'm looking for the RMS value. So I'm going to use voltage source, which is already RMS. Let me just remind you over here, RMS. So I have voltage source is equal 181.82 volts times resistance, which is equal 5 kilo ohms, over Z total, which is equal 5.48 kilo ohms, and angle of 24.32 degrees. Close parenthesis, this is equal 165.89 volts and angle of negative 24.32 degrees. Okay, so this is voltage across the resistor RMS. Next, I'm supposed to find VL peak. In order to find VL peak, I'm supposed to realize that I have already magnitude given, but I'm supposed to also find the angle. So what I'm supposed to do? Again, I'm going to use the voltage division law. So I have VL is equal voltage source times ZL over Z total. At this moment, I'm going to find the RMS value of my voltage, and later on I'm going to convert the answer to peak value. Okay, so I'm going to use again the voltage source RMS. So I have 181.82 volts, open parenthesis. ZL we found is equal to 2.26 kilo ohms and angle of 90 degrees over Z total, which is equal 5.48 kilo ohms and angle of 24.32 degrees. This is equal 74.98 volts and angle of 65.68 degrees. Okay, I'm doing everything step by step. If some of you use different technique, maybe a little bit shorter, it's okay if you get the same answers, but I'm trying to show for every single student how you're supposed to understand this problem step by step. So next, because I have found VL RMS, but the problem is asking me for VL peak, I'm supposed to convert RMS to peak value. Okay, so I have formula which says VL RMS is equal voltage peak let's call this VL peak, times 0.707. So if you want to find VL peak, you're supposed to rearrange the formula, and you will have VL RMS over 0.707. So VL peak is equal 106.05 volts and angle of 65.68 degrees. Okay, so this is voltage peak across the inductor. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So this is equal cosine of the angle which is next to Z total. So I have 24.32 degrees. This is equal 0.911. Okay, and we're supposed to add the word lag. Why? Because this is the positive angle, and because current in RL circuit lags the voltage source. So that's why I'm supposed to use word lag. Next, we're supposed to find the true power. Because we found the RMS value of the current, I'm going to use the following formula. P is equal IR squared times R. This is the formula for power when you want to use the RMS current. So I have current is equal 33.18 milliamps, supposed to raise this to the second power, times the resistance 5 kilohms. This is equal 5.5 watts. This is my true power. Next, we're supposed to find QL, which is equal IL to the second power times ZL, which is equal 33.18 milliamps raised to the second power times ZL, which is equal 2.26 kilohms. QL is equal 2.48 volt ampere reactive. And this is my reactive power. Next, we're supposed to find the apparent power. S is equal I total square times Z total, which is equal 33.18 milliamps raised to the second power times Z total, which is equal 5.48 kilohms. This is equal 6.03 volt amp. Next, we're supposed to draw the power triangle. So I have the true power. P true is equal 5.5 watts. QL is equal approximately 2.48 VAR, and we're supposed to draw apparent power, the phasor which represents the apparent power, and this is S equals 6.03 VA, and this is my angle theta. So we can say that the problem is solved.